Hey y'all, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is a Algebra 1 video, properties of exponents, and we're tasked to simplify, period. Just one word. One word. Your answer should contain only positive exponents, they say, so we want to keep that in mind as well. But as we're looking through, we're going to combine the big numbers separately from the little numbers. So the regular numbers being multiplied by the letters, and then the little numbers, which are the exponents. We treat them a little differently, and we do different things depending on which class of number we're dealing with. So let's go ahead and dive in with number 1. There's a 2 and a 2. So with the big numbers, you just do exactly what you would normally do with them. You would times them, actually. And that's because when I say 2m squared and 2m to the third power, it's 2 times m squared times 2 times m to the third. And because everything's times, it can go in whatever order I want it to go in, which means I can instead write it as 2 times 2 times m squared times m cubed. And so then because of that, we can just take the 2's and multiply them and get 4. Boom, done. The other thing too is that, so I just handled the 2's because they became the 4. The m squared and the m cubed. So you're going to add the exponents when you multiply letters. When you multiply two letters and they have different exponents, you can add the exponents. And here's an illustration of how that happens. So m squared means m times m. When you square something, you're timesing it by itself, and when you square something, or sorry, take it to the third power, then so there's 2 of them. If it's m to the third power or m cubed, then it's m. There's 3 of them. Well, how many of those are there now? Well, there's 1, 2, 3, 4, 5 m's, 5 powers of m. And it always works out like that. It's not going to all of a sudden change and be something else. That's always how it works. So if you're timesing and you're timesing letters, they have to be the same letter. It can't be different letters. Like it can't be like m and then n. Then you wouldn't add the variables at that point. But if they are the same letter, if the base of the exponent is the same letter, m and m, or like on number 3, r and r, as long as that happens, then when you're timesing, you add the powers instead, and you keep the base the same. Kind of like fractions. If you add fractions, you just add the tops. You just add the numerators and you keep the denominator the same. It's almost kind of like that. It's like the base, the m, just stays, but then the top stuff, the numerator kind of stuff, if you will, gets added up. So it's actually pretty similar to that. So then for this one, the 2 would just be a 2. And then I would actually be taking the powers and putting them together. So it's 4 plus, and sometimes I'm plussing, a negative 3. Well, that's the same thing as m to the 4 minus 3, because a plus and a negative right next to each other without a number in between combine. If you have a plus followed immediately by a minus sign, then that's the same thing as just a minus sign. Or let's say you have a minus sign and then a plus sign, that's the same thing as a minus sign. Or if it's plus plus, that's plus, and if it's minus minus, that's a plus as well. And I'll illustrate that off to the side over here. So plus plus, plus minus, minus plus, and minus minus. Right? Well, happy faces. So this is going to be m to the first power, which at that point you wouldn't write the 1 because you don't need to, because that's kind of the assumption, is if it's m to the first power, that's just m. So typically you don't write it. Some teachers will count you off if you leave it there. Other teachers will not, because it is the same thing. It's not like you got the wrong answer. You just maybe didn't simplify all the way. Maybe it's not considered simplifying all the way. But that would be the final answer for that one. So 2m, and then for number 1, it was 4m to the 5th power. Okay. Oh, and by the way, I'm only going to do half of the worksheet, but when I do the next half, I'll tie the 2 together, and then you'll be able to go from one to the next, because I don't want the videos to be too long. So Um, we're going to put these two together. So the numbers, 4 times 2 is 8. And then the letters. So that's going to be r to the negative 3 plus 2 power. Oh, that's r to the negative 1 power. Okay. Now remember, they said only positive exponents. If you have a negative exponent is the same thing as like, if you have r, then it's the same thing as r divided by 1 because, dividing by 1 doesn't do anything to change the number. It keeps the number the same. But now it's a fraction. So now if I look at it and I say, okay, so I'm taking that to the negative 1 power, what does that mean? It means that I'm going to flip the numerator and the denominator. So it's 1 over r. So this is 8 times 1 over r, which you can write as 8 over r. All right, that was a tad tricky, but they do get a little tricky when you got that negative. It's like a negative and a fraction all at once. And that's what that does. So a negative power will flip the base that it's attached to. The negative power will flip the base that it's attached to. So you can either flip it separately like I just did on number 3, or if you already have it incorporated into a fraction, then you would just have it change places. So like if it's in the numerator, then you would flip it so that it's down in the denominator. Or if it's in the denominator, you can flip it so that it's in the numerator. 4 and 2 make 8. And then that's going to be n to the 4th plus a negative 3, aka minus 3. So that's going to be n to the 1st power, which is just n. Okie dokie. Let's go and switch to purple. If it'll let me. There we go. Okay. Little color palette thing wasn't going away. So 2 and 4. Man, they have a lot of these 2s and 4s. All right, so 2 times 4 is 8. And then that's k to the 1st power. If you don't see a power, it's not a power of 0. Anything to the 0 power is actually 1. So if you don't see a power, it's a power of 1, not a power of 0. So if you don't see a power, it's a power of 1. So you're adding the powers, and it's 4 plus 1 is 5. So that's 8k to the 5th power. All right, now they're ramping it up just a tad here. So we've got 2 2's, makes a 4. Here's an x cubed, x negative 1. So that's going to be 3 plus negative 1. 3 plus negative 1, which is the same thing as 3 minus 1, which is 2. So that's x squared. And then put kind of a cloud around the y cubed to show the different kinds of groupings there. Well, that actually, because that's going to be negative 3 plus 3, which is 0. So that's y to the 0 power. Well, what is y to the 0 power? It's 1. So it would just be times 1, which means it goes away, basically. Y to the negative 3 times y to the 3 is the same thing as y to the 3rd power over y to the 3rd power, which would be 1. And if you have 1 times something, then it's just that. So it's just that. It's just 4x squared. All right. 2 and 3 make 6. And then we have a y squared and an x. Those are not the same letter, so I cannot combine them. There's only a 4, so I don't combine that with anything. There are 2 v's. There's a power of 1 and a power of 3, so v4 and u squared. And that's it for that one. All right, time to change colors. And if this is helpful, of course, you can always do the YouTube thing and like and subscribe and all that. But I try to keep a bunch of resources on my website as well, Myers Mathematics. I'd rather that you go check that out and see if there's anything on there that you like. And if there's anything that's missing that you would like to see there, like if you're looking for, let's say, explanations or like an online book kind of thing, or if you're looking for, I don't know, answers to specific math problems, or whatever it is that you want to see. Like if you normally go to, I don't know, like Chegg, or you use Khan Academy or whatever, anything that you want to see, just let me know. I want some feedback because I want to know what you're looking for math help, because I want to be able to deliver that. So I'm working on a bunch of different things, like stuff like this, kind of like Chegg, and some videos and stuff, kind of like Khan Academy has. And so I'm working on a bunch of stuff like that, but if you let me know what it is that you're looking for, then I can tailor some of the things that I'm working on to what you're looking to get help with. So just let me know. Let me know in the comments. Give me some feedback, or you can shoot me an email. My email is in the description below because I am also a private tutor. I am a master private tutor, so to speak. I've been tutoring for over 10 years. It's what I mainly do as of the time of this video. So if you want your first session, go and look at that link or pull up my email and shoot me an email, and we'll set something up. First lesson is always on me. 4 times 3 is 12. Got it? And then I'm going to have a3 and a negative 4. So 3 minus 4. It's 3 plus negative 4. Yeah, but it's also 3 minus 4. 3 minus 4 is negative 1. And so that's going to be an a to the negative 1, which means it's going to have to be 1 over a. So I'm going to have to put the a in the denominator. You can just times it by 1 over a, or you can put it in the denominator. Okay, and then we do the same thing with the b. So it's 2 minus 3, also negative 1, so it's b to the negative 1, which is 1 over b. So that belongs in the denominator. It's 1 over a times 1 over b would be 1 over ab. Since they're both in the denominator, they get times and they just kind of get smashed together. And now we have 1 ab. That's normally called a keg if you only have 1 ab. So 12 over AB is going to be the answer there. All right, so then this is x2 and x3. 2 plus 3 is 5, so that's x to the 5th. Then I have y negative 4, y2. So it's going to be y negative 2. 1 over y squared. So that's times 1 over y squared. Because remember, that's going to be over 1, right? So if you're multiplying across, then it looks like that. And there we go. We got it. All right. What about 11? Well, anything to the 0 power is 1. Remember I said that? So even though, ear was itchy. Even though it's x squared, anything to the 0 power is 1. Anything. So you don't have to think about it too hard. Anything to the 0 power is 1. That's it. That's the answer. Now, for 12, though, it's a little different because we can distribute. When you take something to a power, you're saying that it's getting times by that many times. The negative means I'm going to flip it. So it's going to be flipped. So it's 1 over 2x squared to the 4th power. Well, what does it mean if I take something to the 4th power? If you take something to the 4th power, that means there's 4 of them, right? So there's that one, that one, that one, and that one. There's 4 of them. When something's to the 4th power, it gets times by itself so that there's 4 things that are, the same thing being times up. So that's what that is. And then that's going to be 2 times 2 is 4. And that 2 times 2 is 4. 4 times 4 is 16. And then that's x squared times x squared times x squared times x squared. That's 1, 2, 3, 4, 5, 6, 7, 8 powers of x. Okay. Now, the shorter way to do that is to just times. When you have a power to a power, you just times. We could have just done 2 to the 4th power. So you would still do 2 to the 4th power because 2 is the regular number. And that was 16. 2 to the 4th power is 16. But then the x squared thing, well, when you take that to the 4th power, you just times the powers. And that is the shortcut method. You can always just multiply them out like this, but what if it was a really, really big power? What if it was like 100? Right? Like, well, for one, I don't know what 2 to the 100 power is. But, x squared to the 100 power, you would just times them. It'd be x to the 200 power. But can you imagine, like, sitting around and adding up, like, 100 x squareds? Or, times them and then adding up those powers? No, I wouldn't do that. So you want to know how to do it the shortcut way. And besides, it takes less time. So it's always helpful. All right. Does not want to. There we go. All right, so we are on 13. And I think we're on the last set of 4 here. So remember, anything to the 0 power is 1, but this time the 0 is on the inside. So it's 4 times r to the 0 which is 1. So it's 4 times 1, and then that's 4 to the 4th power. So the trick with taking something to the 4th power is to square it and then square it again. If you do 4 squared and then you square it again, that's the same thing as 4 to the 4th power. That's a little trick. 4 squared is 16. 16 squared is 256. And there we go. All right, so then this, we can distribute the square. And then it's going to be 4 squared and a cubed squared. 4 squared is 16. Remember, power to a power, you multiply the powers. So it's going to be 3 times 2 is 6. That's the trick method that we just talked about for number 12. All right, so then we do it again. So that's 3 to the 4th, which is 3 squared squared. This is actually a little bit more helpful to think about it this way. The way I write it, where it's like 3 squared squared, it looks a little bit less like, looks a little bit more confusing than just 3 to the 4th power. But the way you actually do that in your head makes it so that the math is a little easier. So 3 squared is 9, and then what's 9 squared? Oh, 81. You just did 3 to the 4th power. Okay, and then k to the 4th would be k to the 16th. So all together, that is 81k16. And last but not least, that's a -1. So -1 just means I'm going to flip it, right? So I'm just going to flip it. And since it's a -1, I'm not going to take it to an actual power. I'm just going to flip it because the negative means I'm going to flip. So actually, that was it. That one actually was a little bit simpler than some of the other ones. And that is actually the end of this half of the worksheet. I'll post the other half another time, but wanted to keep it a little bit more on the short side, so that's what I did. Like I said before, let me know how this video landed. Was this helpful? Was it not helpful? Would you like to see different content, different math subjects? I tutor everything from Algebra 1 to Calculus 3, so I stay up to date with all of those subjects. If you want to see anything worked out from any class between Algebra 1 and Calculus 3, which includes like some of the AP classes and stuff like that as well, just let me know. Send it to me in the comments below or shoot it to me in an email, and I'll make it into the next video after the roster of ones that I have scheduled. All right, and with that, I'm off. Have a great day, y'all.